Good day. Our topic for today is about liquid chromatography.
History of liquid chromatography. The first known liquid chromatography is originally attributed to Russian botanist Mikhail Svet, who used columns of calcium carbonate to separate plants compounds during his research of chlorophyll. This happened in the 20th century in 1901. Further development of chromatography occurred when the Nobel Prize was awarded to Arthur John Porter Martin and Richard Lawrence Millington since in 1952. They were able to establish the basic partition of chromatography and also develop plate theory. What is liquid chromatography? Liquid chromatography is a technique used to separate a sample into its individual parts. This separation occurs based on the interaction of the sample with the mobile and stationary phases. Because there are many stationary or mobile phase combinations that can be employed when separating a mixture, there are several different types of chromatography that are classified based on the physical states of those phases. Liquid solid column chromatography is the most popular chromatography technique and the one discussed here. Features a liquid mobile phase which slowly filters down through the solid stationary phase, bringing the separated components with it. Fundamental use of liquid chromatography. Liquid chromatography or LC is a separation technique in which the mobile phase is a liquid. It can be carried out in either a column or a plane. LC is particularly useful for the separation of ions or molecules that are dissolved in a solvent. Simple liquid chromatography consists of a column with a filtered bottom that holds a stationary phase in equilibrium with a solvent. Commonly used stationary phases include solids, a ionic group on a resin, liquid on an inert solid, support and porous inert particles. The mixture to be separated is loaded onto the top of the column, followed by more solvent. The different components in the mixture pass through the column at a different rate. Liquid chromatography is more widely used than other methods such as gas chromatography. It is because the samples analyzed do not need to be vaporized. Also, the variation in the temperature have a negligible effect in liquid chromatography, unlike in other types of chromatography. This is the laboratory equipment or apparatus involved in the process of analysis. High-performance liquid chromatography, formerly referred to as high-pressure liquid chromatography, is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. Chromatography equipment includes all the components needed for separation: columns, frits, flow cells, pumps, detector, collectors, and software to complete system used for high-performance liquid chromatography or HPLC, gas chromatography, GC, and liquid chromatography, and mass spectrophotometers LCMS. It is important to consider the nature of the sample when choosing chromatography equipment, the current platform being used and its compatibility with other components, and the space available in the laboratory are other factors to consider when selecting proper equipment. Chromatography is often the first step in an assay. Downstream application depend on the purity and configuration of each product.
Reagents involved during the process of analysis. The reagents that are needed for our analysis are the solvents of spectroscopic grade, such as methanol or acetonitrile, standards such as caffeine for comparison, double distilled water, and etc. Measurements that are needed or required in the process of analysis. High performance or high pressure liquid chromatography, also known as PLC is a chromatographic method that is used to separate a mixture of compounds in both analytical chemistry and biochemistry so as to identify, quantify, or purify the individual components of the mixture.